Electromagnetic wave and spectrum. To understand electromagnetic wave, let us take some examples. When a stone is thrown in the still pond is disturbed, water ripples are seen. They are formed to transmit the disturbance in the form of waves. When a drum is beaten, it vibrates and sound is produced. When an electric charge vibrates, the electric field around it also changes. The change created in electric field changes the existing magnetic field. This is a continuous process and the created electric and magnetic fields are perpendicular to each other as well as perpendicular to the direction of propagation of wave. This type of wave is called electromagnetic wave. Characteristics of electromagnetic wave: wavelength and frequency. The distance between successive wave peaks is called as the wavelength of wave. It is expressed in meters. The number of wave peaks that could pass through a specific assumed point in a unit time is called frequency. It is expressed inverse of S, which is time inverse. Wavelength is inversely proportional to frequency. That is, lambda is inversely proportional to 1 by v. Therefore, the velocity of wave c is equal to wavelength into frequency, meter per second. From the relation, it is clear that with the increase in frequency, wavelength decreases. Electromagnetic spectrum. The complete range of frequency of electromagnetic waves together is known as electromagnetic spectrum. The formation of rainbow is one of the examples of visible spectrum. The electromagnetic spectrum is a continuous range of wavelengths starting from the smallest wavelength, gamma rays, that is 10 to the power of minus 12 meters, to the longest wavelength, which are radio waves of 1 meter. The wavelengths of visible lights are from 400 nanometers to 700 nanometers.